Welcome to this presentation of our paper for the FNC 2016 conference. The title of our paper is A Survey on Energy Efficient Network Coding for Multi-Hop Routing in Wireless Sensor Networks. This paper has been written by Emmanuel Migabo, Karim Djouani, Anish, Kurien and Thomas Olwal, all from the Department of Electrical Engineering and the French South African Institute of Technology at the Djouani University of Technology in Pretoria, South Africa. For any inquiries, do not hesitate to contact me at the email address provided as below, migabo.emmanuel@gmail.com. Well, in terms of our presentation outline, we'll start by giving a quick background and motivation. Then we're going to provide a quick introduction. Thirdly, we're going to speak about network coding challenges in wireless sensor networks. Before we speak about a classification of energy efficient network coding protocols. Then we're going to speak about network coding metrics in wireless sensor networks. Then we're going to also speak about network coding research opportunities in wireless sensor networks. And finally, we're going to give a conclusion and some future work. In terms of background and motivation, there are numerous network coding techniques for energy efficient routing in wireless sensor networks. To the best of our knowledge, no literature survey of these techniques in a multi-hops wireless sensor network scenario has been carried on. Therefore, there's a need for a survey article with classification of existing network coding protocols as applied in wireless sensor networks. There's also a need for awareness of network coding protocols' merits and demerits. There's also a need for awareness of network coding protocols' implementation challenges. There's also a need for network coding protocols evaluation, metrics, and formulation of open research opportunities. Therefore, the goal of this paper is to constitute an introductory article to energy efficient network coding in wireless sensor networks. In terms of our brief introduction, I'm going to quickly start by defining or reminding ourselves about the definition of wireless sensor networks, or the concept of wireless sensor networks. A wireless sensor network is a network of large number of sensor nodes constrained in terms of energy, processing, and memory resources. Wireless sensor networks are usually used in military as well as civil applications for sensing or capturing of information about physical phenomena and collecting as well as multi-hop routing this information to the base station for processing, analysis, and interpretation. Minimizing energy consumption is key wireless sensor network design criteria, and that's well known. Now let's speak about network coding. Network coding is an intelligent way, could be binary or linear way of aggregating data packets. This results in reduced number of data packet transmissions, which is equivalent to reduced energy consumption. There are existing energy efficient routing protocols in wireless sensor networks, which coupled with network coding protocols have demonstrated further enhancement of energy efficiency capabilities. Sensor nodes design has undergone some recent development that led to powerful microcontrollers, and these development in the area of microcontrollers designs has allowed to trade more and intelligent computation for less transmissions in order to reduce energy consumption, and that's the main idea behind network coding as used in wireless sensor networks, keeping in mind that these devices are constrained in terms of computational and memory, computational capabilities and memory. Therefore, it's a good idea now that we've got powerful microcontrollers. However, this is faced with many practical or integration to the network stack challenges. Some of the main energy efficiency related network coding challenges are: first of all, we speak about fast coding. then compulsory decoding reliability, real-time constraint, and all of these challenges faced with simultaneously achieving low complexity encoding and small memory storage. In terms of network coding challenges in wireless sensor networks that I've just listed, I'll start by speaking about fast coding. There is what is known as interflow network coding, for which the complexity, we're speaking about time complexity now here, it's quite low. However, the complexity is quite low. However, when you speak about intraflow network coding now, the complexity is linear, and therefore intraflow network coding are known to be more expensive in terms of time complexity. For n data packets, linear network coding has a polynomial time complexity that's bounded by O(n) squared, keeping in mind that n is the number of data packets being encoded or linearly combined. It's a logical explanation that the more computational time we have, the more energy consumption, of course. Let's speak about the second network coding challenge that we've identified throughout the survey of the different papers we've read. It is the compulsory decoding reliability. Transmission reliability is mandatory, and reliable reception of n linear combinations is compulsory for decoding, failure to which network coding produces opposite effect, meaning we get more energy consumption than the energy efficiency we are trying to achieve, which is totally the opposite of our aim. The third challenge, is the real-time constraint. Decoding of the encoded packets, of course, is subject to reception of a minimum of n encoded packets, especially when we speak about linear coding, because we think of Gaussian elimination, and that requires a minimum of n encoded packets in order to decode n non-encoded packets. Okay. That involves waiting and naturally introduces time delays. And that's a problem for real-time wireless sensor networks applications, and there are plenty of these type of applications. Now let's speak about energy efficient network coding protocols. A quick classification. According to our survey, we came up with two main classification approaches of wireless sensor network coding. On one side, we've got local and global network coding protocols. And on the other side, we've got intra-session and inter-session network coding protocols. Local network coding protocols are the ones in which coding happens at each single sensor node, as opposed to global network coding protocols, which are the protocols in which coding only happens at source sensor nodes. Either of the two, local or global, could also be classified as binary or random linear. When we speak about the binary network coding protocol, we refer to network coding protocol where the non-encoded packets are regarded as binary sequences, and their combination is done by means of bit-level operations. We're speaking about your XOR type of operations. And an example is a well-known binary network coding protocol, which is known as Physical Layer Network Coding Protocol, PNC. We also speak about the TWRC, or two-way relay coding, and many more. Going back to the random linear network coding, these ones consist of linear combinations of non-encoded packets, of course, with random coefficients. Random coefficients are usually generated from either finite or infinite fields. One of the most well-known type of random field for random coefficients is the Galois field. The coding for random linear network coding protocols types is done by means of Gaussian elimination, as mentioned in the previous slide as well. Going on the other side of the classification, we've got intra-session and inter-session network coding protocols. When it comes to intra-session network coding protocols, it consists of the coding of packets from the same session or source node, while the inter-session network coding consists of the coding of packets from different sessions or source nodes. So usually the intra-session network coding protocols are designed to address packet loss or error correction. meaning to provide error correction. While the inter-session network coding protocols are usually or often designed to reduce the number of packets transmissions. And that's where energy efficiency comes in. Although energy efficiency is also somehow linked to packet loss reduction or error correction. Yeah. Carrying on with our classification, we identified 5 well-known or most commonly known network coding protocols that we're going to speak about. The first one is the COPR. The COPR is classified as a local and an inter-session random linear network coding protocol. Its advantages involve the fact that it's an energy efficient network coding protocol, because its energy efficiency has been proven to improve over the back pressure routing, which is its predecessor. In terms of drawbacks, it however involves high computing complexity in session scheduling. And a research opportunity identified here with regard to the COPR is to develop an algorithm for reduction of session scheduling time. The second one is sense code. The sense code protocol is local, inter-session and binary. It has the advantage of being reliable. It involves a lot of reduction of packet error rate. However, it suffers from poor connectivity, and that's a big problem in dynamic wireless sensor networks. We're speaking about your mobile type of wireless sensor networks here. A research opportunity here is to develop cooperative network coding to improve network coding connectivity. So as sensor nodes are moving, there could be a mechanism for them to exchange small packets or any other type of mechanism for them to keep up with each other, and that's what I refer here to as cooperative network coding. The third one is code drip. Code drip is a global intra-session random linear network coding. It enjoys the advantage of being highly resilient to dissemination failure and has got a fast dissemination. However, it's not suitable for high volume of sense data. The opportunities for research around code drip protocol is to develop less complex packet combination operations. The next one is the MOE protocol. The MOE protocol is a random linear network coding protocol. It enjoys the advantage of having high throughput. It has proven to be having high throughput, but suffers from low reliability. The research opportunity here is to evaluate the effect of low reliability on its throughput, for instance. There is another very interesting energy efficient network coding protocol that has been developed within our labs, named the gradient based routing with network coding protocol, GBRNC. The gradient-based routing network coding protocol, GBRNC, is an inter-session and local energy-efficient wireless sensor network. Network coding here enhances energy efficiency performance, and its main objective when it comes to GBR, let me rather say when it's coupled with GBR, is to reduce the interest packets duplication. As we all know, we are probably familiar with GBR. It's a protocol that requires that a certain number of interest packets or packets to update that are used to update the routing tables are disseminated prior to at certain intervals of time prior to actual routing. This is to update the routing tables. Now, network coding comes here as a way to reduce the dissemination of these packets and hopefully improve the overall network energy efficiency. The main drawback of this method has been identified to be the selection method for network coding scheme in order to achieve reliable decoding, because as we mentioned, without reliable decoding, network coding is useless. A research opportunity identified here is to say, how can we have a wireless sensor network connectivity aware selection process of appropriate network coding schemes? And the hypothesis that came up from our labels to say this selection will surely improve the probability of successful network decoding process, and therefore will improve the overall energy efficiency. The expected result is the reduction in number of retransmission attempts and improved energy efficiency, as I've just mentioned. One solution has already been proposed by the same authors through a paper that was named Cooperative and Adaptive Network Coding, COADNCGBR. Some of the most common network coding metrics in wireless sensor network, because it's very important to have an idea on the evaluation of network coding performance. Network coding protocols aim at achieving energy efficiency, fast data dissemination, minimum packet loss, and reliable decoding of encoded packets. Its performance evaluation is often done in terms of average packet delivery ratio, which is similar but different to throughput, because throughput is the number of successfully decoded packets over time, while PDR is actually the number of successfully decoded packets over the total number of packets. When you speak about average here, we refer to the mean of this PDR for all sensor nodes. The second very important network coding metric is the network resilience. Multidimensional metric in its type is a function of average PDR, delay, throughput, fairness, and many more. One of the tools that is usually used to portray the performance of a network coding with respect to network resilience is known as the caveat diagram representation. The third one is the packet dissemination latency. Duration from source to sync node, that's what it represents. It's dependent on encoding and decoding times, so they form part of this overall time elapsed from source to sync node. It evaluates the network coding complexity level. It's a very essential network coding metric for real-time wireless sensor network applications. It's bounded between, or it has been proven to be bounded between ON and ON squared for n encoded packets. In terms of network coding research opportunities, although some have been identified here and there already throughout this presentation, wireless sensor network overall performance can be improved through network coding. That has been proven. Two main performance improvement network coding opportunities have been identified amongst many. These are the data aggregation. More data packet delivered, less number of transmissions, less time. Higher throughput, less energy consumption, less transmission errors. The second one is the reduction of network information packet for mobile wireless sensor networks. Mobile wireless sensor networks have the characteristic of having a fast-changing network configuration. Routing table updates packets often is costly in terms of energy and other resources, such as computational resources. Also, network coding can tackle wireless sensor network topology uncertainty and alleviate, therefore, the need for exchange of update data packets. To conclude our presentation, this paper has provided a brief and clear idea on network coding protocols in wireless sensor networks. Different research opportunities have been presented by network coding in wireless sensor networks and have been highlighted based on the merits and demerits of the existing network coding protocols. This paper constitutes an essential tool to start with when exploring the concept of network coding as applied in wireless sensor networks. Further study would like to do would include much more details on the network coding classifications, for instance, and an evaluation of their energy efficiency performance, for instance. There are many more that we could do to improve this survey paper. In terms of references, it's important to note that the main reference for this paper remains a dissertation for a master's degree, but that has been accompanied with these other 18 references as mentioned on these two slides. Thank you very much for your attention. For further information, do not hesitate to contact me, Emmanuel Migabo, at the email address provided as below, migabo.emmanuel@gmail.com. Thank you for your time.